Hello everyone. In this video we'll solve question 1 to question 10 from chapter 2 describing motion. Question 1. A car starts from rest. The table shows the reading from its speedometer every 10 seconds. Which road describes the car's motion in the first 30 seconds and in the last 30 seconds? Let's look at the car's motion in the first 30 seconds. So the car's speed is increasing in the first 30 seconds. That means there is some acceleration. So during the first 30 seconds there is non-zero acceleration. In the next 30 seconds the car is moving with constant speed. So the correct answer would be option D, non-zero acceleration during the first 30 seconds and constant speed during the last 30 seconds. Question 2. The diagram shows speed time graph for 4 different bodies moving for 6 seconds. Which body traveled the least distance? In a speed time graph, the distance traveled by the body is given by the area under the curve. Now we have to determine what's the area under the curve for each of these graphs. Let's look for the first one. So this is a triangle. So the area under the triangle, area of this triangle is given by half times base times height. So it is half times 6 times 8. So half times 6 is 3, 3 times 8 is 24. 24 meter is the distance traveled in the first graph. Let's look at it for the second graph. For the second graph, there are two triangles which are to be considered. The first triangle is here and this is the second triangle. For the first triangle, the area is half times 4 times 8 and area of the second triangle is half times 2 times 4. So half times base times height. So base is 2 here for the second triangle. So half times 4 is 2, 2 times 8 is 16 plus, so these two get cancelled. So we have 4, that would be 20. So 20 meter is the distance traveled in the second graph. So here the distance traveled is 20 meter. For the third one, the distance traveled is this area of rectangle. So the area of this rectangle is given by 6 times 8, which is 48 meters. For the last one, we can split this into two parts. One is area of this rectangle plus area of the second rectangle. Area of the first rectangle is given by 4 times 8 plus the second rectangle is given by 2 times 4. So 4 times 8 is 32 plus 8, that would be 40 meters. So the distance traveled in this fourth graph is 40 meters. Among these four, option B has the least area under the curve. So the correct answer is option B. Question 3. The velocity time graph for a car is shown. What is the distance traveled by the car in 35 seconds? If we have velocity time graph and if we have to find the distance traveled by the car, we have to find what's the area under the graph. To find the area under the graph, we can split this graph into three parts. One can be this triangle, then a rectangle, then a trapezium. Now we are actually covering the time from 0 to 35 seconds. We have to find what's the area under the triangle, area of the triangle. So this will be half into base into height, so half times 10 times 10 plus area of this rectangle is length into breadth. Let's look at the length. Length here is this part of the graph, that is 25 minus 10, 15, and breadth is 10. So for the second part it is 15 times 10 plus, for the area of trapezium we can use the formula half times base times sum of parallel sides. So let's say we have L1 and L2 are parallel sides. This is the base. The length of the base is 10. So if I use area of trapezium half times base times L1 plus L2, then we can substitute these values in here. Half times base is 10, L1 is 10, and L2 is 20. So if you finding area under the trapezium difficult, you can also split this into two parts. You can make this as a square and the other part is a triangle. So you can find the area of this square and the area of this triangle and you will get the same answer. So from here, this is 1s are 5s are 5 times 10 is 50 plus 15 times 10 is 150 plus, so this is 2 1s are 2 5s are, so 5 times 30, so 5 times 30 is 150. So it is 50 plus 150 is 200, 200 plus 150 is 350. So this will be 350 meters. Correct answer is option B. Question 4. The speed time graph for a train is shown. Which region of the graph shows the train moving? If the train is moving, then the train will have non-zero speed. The speed will not be zero. If we look at this graph, for this section P, the speed is 0, whereas in any other section of the graph, the speed is non-zero. So we'll make a small note. So for a moving object, speed is non-zero. So in this graph, region Q, R and S have non-zero speeds. So the correct answer is option B. So Q, R, S are the region of the graph where the train is moving. Question 5. A man stands next to a railway track. A train traveling at 40 meters per second take 2 seconds to pass the man. What is the length of the train? In this question, we have been provided with the speed. Speed is 40 meters per second. The time is given to us 2 seconds. They are asking us what is the length. Length is nothing but the distance of the train. Distance covered by an object moving at 40 meters per second for 2 seconds. So this is unknown. We can write the formula speed equals distance traveled divided by time taken. So if I want time will be so we know time, we need to find what is the distance or the length. So I'll erase this part. So distance can be written as speed times time. Distance can be written as speed times time taken. So if I substitute, this will be 40 times 2, which is 80 meters. So distance, it's the same as the length of the train now. The correct answer is 80 meters. What is used to determine the distance traveled by an object in motion? So if I have to find the distance traveled by an object, I can use the area under the speed time graph. So it is option B. The graph shows motion of a car. Which row correctly describes this motion? Now, looking at this, I can say that acceleration is a constant. Acceleration is the gradient of speed time graph. If I look at the gradient here, gradient here, gradient here, the gradient is same throughout this graph. So I can directly eliminate option C and option D. Now between option A and option B, I have to determine what's the distance traveled. Distance traveled in a speed time graph is area under the curve. So the area under the curve will be, so I can take it as a trapezium. So half times the base is 20. Now the sum of parallel sides, we have two parallel sides. So this is the first parallel side here. So that's 5 units. The second parallel side is here, which is 15 units. So you can write 5 plus 15. This is 2 times 10 is 20. So 10 times 20, that would be 200 meters. Correct answer is option A. A speed time graph is used to describe the motion of an object. Which quantities are calculated from the gradient of the graph and from the area under the graph? When we are considering speed time graph, the gradient of the graph provides acceleration and area under the graph provides distance traveled. So it's option A. Question 9. Which quantity is equal to acceleration? So acceleration is gradient of speed time graph. It's option D. Question 10. A skydiver jumps from an aeroplane and falls towards Earth. Which statement is correct when the skydiver has reached terminal velocity? When the skydiver reaches terminal velocity, let's say this is the skydiver is reaching terminal velocity. The weight of the skydiver will be equal to the air resistance. Let's say the weight is acting downwards, the air resistance acts upwards. If these two forces are equal, let's say this is force due to air resistance, when these two forces are equal, then the object will move at constant speed because of inertia. So the graph looks like this. If I take velocity time graph of the skydiver, right? This is velocity, this is time. Initially it will be a straight line, but later on it curves like this and becomes a constant. So this flat line is where the air resistance and the weight are equal and the net force becomes 0. So the object will move at constant speed. This velocity is called as terminal velocity. Looking at the option, the speed of the skydiver speed is decreasing is incorrect. The skydiver speed is increasing is also incorrect. The skydiver is moving with constant speed is correct. Let's also take a look at the fourth option. The skydiver's speed is 0. This is incorrect because forces being balanced does not mean the object is at rest. Forces are balanced means whatever is the force of gravity is equal to the air resistance. But if an object is already in motion, it continues to stay in motion. So the object, or the skydiver in our case, will continue to move at the same speed for any length of time.